Let's look at some review questions first, okay, and then we'll move to average value. Okay, and hopefully I'll have some time to check your homework from last night. You guys had second fundamental theorem of calculus last night. Hopefully you guys did that. It'll be second fundamental theorem will be on your next test. The problem with it being on your next test is by the time you test on it, it'll be 3 weeks later. Okay, so try to keep up with it. I'll review with you. Maybe I won't. Before when I tell you what's on the test. But I just want to say that in the past, it's about 2 weeks before they test on average on second fundamental theorem of calculus, and a handful always get it wrong. And I don't think second fundamental theorem of calculus is very hard, but it is hard in that we don't use it a lot. Okay, so you forget how to do it. If you do this integral, okay, you might be like, wait, what should I set the u equal to? Should I set it equal to 4x? Or should I set it equal to 5x? Or, oh boy, do you guys see that? Do you see it's an oh boy problem? Okay, right. Why is it an oh boy problem? They're not tied, yeah, exactly, they're not tied together, okay? Now, if I had done this, it would be tied together. Does that make sense? This would be, oh no, okay, you guys good with that? This would not be oh boy. But they're not tied together, they're just strung together with these pluses and minuses, so it's actually two different problems. If I did the left side, what would my u be equal to? 4x, okay? If you take the derivative of both sides, because you do this for every problem, you would get dx is equal to du over 4. You replace two things. What two things do I replace? My u and my dx. So I would get the integral of 3 cosine u times du over 4, okay? Then what do? I would pull out my scalar, so this would look like an easier problem, okay? And from here I'd say, okay, first of all, do my x's cancel out? There are no x's, so that's great. I should only have u's. And then secondly, is this an easy antiderivative, or is it something on my formula sheet? It's something on my formula sheet, right? And now you actually have a formula sheet, so I'll refer to it a lot. Okay, so if you want to, you can write down the integral of cosine u is actually sine u, okay? Sine u plus c. So this is going to be 3/4 sine u plus c. And of course, if you wanted to, you could put 3/4 c. But remember, c was just some number you didn't know anyway, so 3/4 c is still some number you didn't know, so it actually didn't help you any, okay? All right, this is a great answer. It's just the wrong answer. Okay, so make sure you come back and put in your 4x, and you have the final answer. Okay, now I need to do the right side over here. Okay, on the right side, I just want to, let me do the same thing, but let me see if I can get a pattern going here. The integral of 3 cosine 4x was 3, there's the same 3 there. Okay, 3 sine 4x. So all I did was I changed the cosine 4x to sine 4x, because the integral of cosine was sine, right? And then I divide by the derivative of my u, right? I divide by the derivative of 4x, which is 4. So what if I applied the same principle over here? Because I'm trying to find the integral of negative sine 5x dx, okay? Well, I still have a negative 1, right? Just like you have the 3, it pulls down, okay? What's the integral of sine u? Okay, negative cosine u, right? And what's the derivative of 5x? So I divide by 5. Do you guys see that? It's kind of the same pattern. This is the walking backwards, okay? And so if I combine these two answers, this is negative times negative, so that's a positive. So I'd say plus 1/5 cosine 5x plus c. Do you see how I did that? So eventually you want to move fairly quickly with these trig functions, because you don't want to spend a lot of time, doing the u substitution if you can memorize some of these tricks. All right, we'll do more of these tricks later. Okay, let's do another problem. Now this is a definite integral, okay, so we don't have Charlie, okay. Notice, guys, on your second fundamental theorem of calculus problems from your homework last night, you didn't have Charlie, okay, because it was kind of like a definite integral. All right, so over here I have limits here. Now what you do first, though, is just ignore those limits, okay. Don't try to do the limits at the same time you're doing the u substitution, okay? That's way too much for any one person, right? What's my u going to be here? Okay, what's the derivative of u? Okay, and then you solve for dx. What were the two things I substitute? my u, and my dx. Okay, so go ahead and put those in. Okay, what's my next step? What do you want to take the integral right here? Or do you want to pull out the 1/5? It's up to you. Okay, so if you pull out the 1/5, at this point, I should have an easy antiderivative, or I should have something that's on my formula sheet. Is it an easy antiderivative? Yes, I guess that's relative, what easy is, but it's not a bad one. You add 1, divide by 3/2, but dividing by 3/2 is the same as multiplying by 2/3. So you get 2 over 15, u to the 3/2 plus Charlie. Okay, this is a great answer. It's just the wrong answer. Make sure you come back, put in your u, okay? And this one doesn't have a Charlie, right, because it's a definite integral. So my u is going to go from -1, my x is going to go from -1 to 2. Okay, I want to stop here and say this is a mistake the students make here. They'll go here and they'll say this comes from -1 to 2. Okay, do you see that they didn't plug into the right answer, right? They plugged into the great answer, okay, which isn't what you want to plug into. But I want to stop here and say, well, if this is u, I can't plug my x's into it, right? Because these are x numbers. But guess what? You can actually plug your u's into it if you want to. It'll give you the same answer, okay? So if you think it's easier actually here to plug in your u's, you can just change these x's to u. And you have a formula that relates u and x, right? So if x is 2, do you see that u would be equal to 5 times 2 plus 6? So u would be 16. Is that right? 16? Yeah. And if x is -1, then your u would be 5 times -1 plus 6. And so that would be +1. Okay. And so do you see that I could take this from 1 to 16 and I could actually plug in right here, which would be the exact same thing as plugging in down here. Okay, any questions on how to do that? All right, so let's do it. Let's see what this answer is. I'm going to plug into my x's just because I've gotten it this far, but it really doesn't matter what I plug in. So if I plug into my x's here, I have 2 over 15 times, if I put a 2 here, that would be 10 plus 16, which is 4. Oh, wait, I think I forgot my, I'm sorry, I forgot my exponent over there. So 4 raised to the, wait a minute, 2, that's 16. Raised to the 3/2 there, that's better. Put in your -1, that's going to be 2 over 15, -5, so there will be -5 plus 6, which is 1, raised to the 3/2. Slap a minus sign in between, okay? I'm going to root this number first, so the root of 16 is 4, raise 4 to the 3rd power, that's 64. So I have 2 over 15 times 64. 1 raised to any power is 1. So this is going to be, unless it's raised to the, yeah, it's actually going to be 1, yes. I was going to say unless it's raised to the 0, but it's still 1. So 2 over 15 times 1, okay? And so what do I get here? 64 times 2 is 128 over 15 minus 2 over 15, so I get 126 over 15. Okay, any questions about how to do that? You guys got the same thing? Okay. All right, so that's a little bit of review. I want to go to average value now. So go to your formula sheet, please. We're looking at the second paper of your formula sheet. So the, look at the second paper, go to the back of the second paper. So page 4. So basically page 4 of your formula sheet, okay? You have this formula called average value. Okay, go ahead and write this formula here. This is a formula for average value. It's 1 over b minus a times the integral of f of x dx from a to b. Okay, this is average value. It's the 3rd formula on your 4th sheet. Patrick, did you pick up a yellow sheet? Okay. Okay, so we're looking at page 4, okay, and the 3rd formula on page 4. Okay, so what is average value? Okay, so we're going to talk about what average value is. And what it is it's the mean value formula for the integral, okay? So remember with mean value, we said there's some number, okay? There's some number where the derivative is equal to the slope of a secant line, okay? It isn't always true, but if the function is differentiable on the open interval and continuous on the closed interval, there's always one number where this is true, okay? And so for average value, what we're saying is there is some number c, okay, where the area under the curve, okay, is equal to a rectangular area. Okay, and so what do I mean? If I have some function, so I'm just going to make a straight line. If I have some function between a and b, it doesn't have to be a straight line. Okay, actually, let me, just so that you don't think it has to be a straight line. Okay, I have some function. Okay, if I get the area under that curve, so I'll call this function f of x. Okay, if I get the area under that curve from a to b of f of x, so that's this green shaded in area right here. Okay, if I can get the area under that curve, isn't that represented by the integral of f of x dx from a to b, right? Isn't that what the definition of an integral is? Okay, so that's this green area. If I take that same green area, I don't change the area, so if this is 5, okay, I go and draw a rectangle with the same area, okay, but now this rectangle is limited between a and b, okay, and so do you see, if I take the same area and I want form it into a rectangle, it would kind of just be maybe something like this. Does it make sense? I'm trying to copy the same area. So if I made this area the exact same, does that make sense? Then this is what it would look like. And this number here, okay, if I duplicate the area, this y value here, that is what we call the average value. Okay, that is the average value. The y value that comes up when we make this area equal to this area over here. Okay, and if you're being really technical, what the mean value theorem for integrals would say, or what average value says, is that there is some c, and I don't, I can find that c, but there is some c where if you come up, that's probably not the right place. Let me see if I can try to make it more like, it's going to be over here. Okay, there's some c where if I came up and found the y value of that c, that y value is going to be the same as this y value. Okay, that's all average value, the mean value for theorem for integrals is. Okay, you don't actually need to know the mean value theorem for integrals. What you really need to know is the formula for average value. Okay, but this visually is what average value is. Okay, we're going to show that visually with M&Ms in a few seconds. But before we get too far, you guys have your formula sheet out. On the top page of that same page that you were looking at, it says the first fundamental theorem of calculus. Let's go ahead and fill in your first fundamental theorem of calculus. You're given f prime instead of little f. That means right here, this should be little f for you, and this right here should be little f for you. Okay, you guys filling that in correctly? Okay, and then average value of a function. Okay, you've already filled that one in. There's kind of a right side to it. Okay, and see if this makes any sense to you. Because of the first fundamental theorem of calculus, okay, the antiderivative of this is this right here, right? So this is actually the same thing, these two things. And if you think about, when you integrate a rate, you get an amount of change. The average value is the amount of change over the time value, if that makes any sense, that has passed. Okay, so that's another way to think of it. All right, I'm going to erase this because I wanted you guys to see that, this integral of f of x is really this capital F of b minus f of a, first fundamental theorem of calculus. Average value is confused a lot with average rate of change. I say a lot, like almost all the time. Okay, I confuse it too. All right, so this is another formula you need to know, average rate of change, which is different, like similar but different to average value. So please go to the very front of your formula sheet. It's on the very front, it's like your fourth or fifth formula. And please write this formula for average rate of change of f. Okay, this is your formula for average rate of change down here on the bottom. Okay, why is it on the front of your formula sheet? Because you already knew this formula coming into calculus. Okay, this is really just a formula for slope, right? It's y minus y over x minus x. Okay, so even though we get it all confused, it's just because they both have the word average in them, but they're totally, well, they're not totally different, but they're similar but different. Okay, so let me just talk to you guys about this and see if this makes sense. Even their units are different. Okay, because if this were like meters per second, if I were doing v dt, okay, so let's just do v of t dt. So that means this would be a time value, this would be a time value, these would be time values, right? So I'm using time just because it's easier for us to see units on time. Okay, if this were, if f were v, so down here, let's make this fv. So this would be v and v, okay? The units here would be meters per second, okay, velocity is meters per second, times this change in time would be seconds, Does that make sense? And then over here, you would divide this by seconds. So this would be meters per second per second. So do you see that you come out of here and get meters per second? Does that make sense? Because this second would cancel with this second, but you still have a meters per second. Okay, over here, if I did this problem, it'd be meters per second on the top, but then this would be times on the bottom, so it'd be second. And this would come out and it'd be meters per second squared. Does that make sense? So they even have different units, although they're similar, so that's why we get them confused. Okay, so the difference between average value and average rate of change. Let's talk about what visually average value is. So you have this problem on the back of your notes, okay? And you have this function. The function is 1 plus x squared. And the problem is telling you to get the average value of the function 1 plus x squared between negative 1 and 2. Okay, so what is that saying? Well, that's saying, well, first of all, go look at your function. This function here is 1 plus x squared. It's been graphed for you, okay? Go between negative 1 and 2. So here's negative 1, and here's 2, okay? Get the area of that function under the curve, okay, between negative 1 and 2. So I'm going to pull down negative 1 here. I'm going to pull down my 2 value here. I want you to put your M&Ms, okay, under the curve to represent the integral here, okay? So take your M&Ms out of your bag and put them here, and don't overlap your M&Ms because your M&Ms are going to represent your area under the curve. Okay, so put your M&Ms here. Don't remember not to eat your M&Ms, okay? I'm not saying they're not edible, okay? It's just that because of COVID, we shouldn't eat it, okay? So this right here, or at least I shouldn't see you eat it, okay? This right here are your M&Ms. Okay, now that's going to represent the area under the curve. Everybody good with that? Okay, now what is the average value? The average value is the rectangle formed by this same area. Okay, so just do the best you can. Put your M&Ms there, push them together, but don't overlap them. Okay, and what we're going to do is we're going to take that same area, form it to a rectangle in between still the same interval. Okay, in the same interval. Okay, so what I'm going to ask you to do is after you decide how many M&Ms are there, okay, but you can't change it. Okay, put your M&Ms there. Push down your M&Ms. Push it down so that you get it into a rectangle. So, you know, remove these M&Ms here, okay, and push your M&Ms down. Does that make sense? So use the same number of M&Ms, the same area, okay, between negative 1 and 2, but you're gonna now be in a rectangle. And this y value of the rectangle, okay, so this value right here, this is your average value, your f average. Okay, so read that off your graph. Tell me what you have, and we're going to see if we can calculate that using the formula. What'd you guys get? Push it down, and it was just an estimate because, of course, M&Ms aren't a perfect, simulation for area. Jackson, what'd you get when you push down your M&Ms? You're getting 2, Alex. Jackson, did you get 2? Okay, so we're saying about 2. Okay, so that's the y value. That's what average value is. It's the y value formed when you keep the same area in between the same endpoints, okay? And let's see if we calculate and still get 2. Remember what average value is. F average equals 1 over b minus a, the integral from a to b of f of x dx, okay? My a is going to be negative 1. My b is going to be 2, okay? So this is going to be 1 over 2 minus negative 1, the integral from negative 1 to 2, f of x dx. Okay. Over here I got 1/3. Okay, my f of x dx, actually, is that 1 plus x squared? 1 plus x squared dx. Okay, if I integrate this, I'm going to get x plus x cubed over 3 from negative 1 to 2. Okay, first I'm going to plug in the 2. So remember, this 1/3 is going to be multiplied by all of this. Okay, so first I plug in the 2, which will be 2 plus 8 over 3. Then I plug in the negative 1, so that's going to be negative 1 plus negative 1 over 3. Okay, then I put a minus sign in the middle. That's the first fundamental theorem of calculus. And of course, I'm going to multiply everything by, oops, not 1/2, 1/3 when I'm done. Okay, my goal is to get 2. Let's see if this will happen. So 2, or something close to 2. So 2 plus 8/3, that's going to be 6/3 plus 8/3. So I get 14/3 minus, this will be 3/3. So minus negative 4/3 times 1/3. Okay, this is negative, negative, so that's a positive. So I get 1/3 times, did you guys get 1/3 times 28? No, that's not 28. 18/3. Okay, but that's really 1/3 times 6, which is 2. Okay, so we calculated average value using the formula, but you could also use M&Ms, obviously, to count average value and be pretty accurate. Okay, on your AP calculus test, I don't think you're allowed to bring M&Ms in, so you're going to have to do it this way. All right. Okay, and then if you look at your homework, the first 3 problems are really just doing average value. Yes, Ben? Where? You're good? Okay. Okay. All right, the next thing I want to do with you guys is kind of a word problem. Okay. Oh, not that one. This one, sorry. Okay, what if they said find the C value, okay, where you get the average value? So what are they really saying? They're saying come back over here. If you say the average value is 2, okay, so I'm going to erase all of this. Okay, if you say the average value is 2, what X values does that correspond with is what it's saying. So if I say the average value is 2, that means the Y value is 2 here, and I actually have 2 places on my function where the Y value is 2. And so graphically, I can see that the 2 C values, okay, are going to be negative 1 and 1. Do you guys see that? Kind of like mean value theorem. They always ask, well, what X value does this happen at? Well, this mean value, this average value happens at X equals plus or minus 1. But how do you actually calculate that? So the way you calculate it is you set your Y equal to your function. So that'll be 2 is equal to 1 plus X squared, okay? You solve for X. And you see I get X equals plus or minus 1. So it makes a lot of sense that you get what your graph said you would get, okay? And then they can also say, sketch the rectangle where you have the same area, okay? So all that means is take your M&Ms, okay? You push down your M&Ms between negative 1 and 2, okay, until you got a height of 2, okay, so that's a height of 2. And then draw that rectangle, and the area of this rectangle, okay, is going to have the same area as the area under the curve of f of x between negative 1 and 2, okay? All right, now you can have a word problem. And let's see what this word problem says. This word problem says you've got a table. They want you to do a left Riemann sum with these 3 subintervals and estimate the average value. Okay, this is way overwhelming. I just want to let you know, there's a lot of things they're asking here. But the most obvious thing that they're asking is do a Riemann sum, right? So do a Riemann sum, because if you do a Riemann sum, you know that's like half of the credit right there, okay? So let's go ahead and do a Riemann sum. Now, how would I do a Riemann sum? I need 3 subintervals. Well, guess what? 5, 23, 9, 29. I'm just going to plot these numbers. 12, 36, and 17, 27. Again, it doesn't have to be to scale. It's nice if it's relatively correct. Okay, even if you did it wrong, it wouldn't matter. You're going to use the right numbers to calculate the left Riemann sums. It says use 3 subintervals. So I go from 5 to 17 and make sure I have 3 subintervals. So here's 1, my red subinterval. Here's 2, my blue subinterval. And here's 3, my green subinterval. Okay, I've got 3 subintervals. Once you get your subintervals, you pull up from the left side because it wants a left Riemann sum. So on my red rectangle, I'm going to pull from the left side to get the Y value. On my blue subinterval, I'm going to pull up from the left side, okay, to get the Y value. And on my green subinterval, I'm going to pull it from the left side to get my Y value. Okay? Then you get the Riemann sum values. So the red triangle would be 23 times 9 minus 5, which is 4. The blue rectangle would be 29 times 12 minus 9, which is 3. And the green rectangle would be 36 times 17 minus 12, which is 5. Okay, so I'm going to add up, use my calculator, add all these up. So 23 times 4 plus 29 times 3 plus 36 times 5. And I'm getting 359. Did you guys get 359? Okay, so that is the area under the curve, so to speak. Okay, why do we even do Riemann sums? The whole reason we did Riemann sums is to estimate integrals, right? So this is the integral of f of x. So this is f of x right here. We're estimating. See, if you think about it, this right here was f of x. This x-axis was your x. Okay, so this is the integral of f of x dx. Everybody good with that? I mean, that's what the Riemann sums is. That's why we learn Riemann sums the same time we learn integrals, okay? Because Riemann sums are an estimate of your integral. And I guess to be technically correct, it's an estimate. So it's about, you know, the area under the curve. I don't know exactly what f of x is. All right. So if this 359 is what f of x is, and just make sure I understand, it's actually between 5 and 17. So Riemann sums are definite integrals. You've got limits to the endpoints, okay? So from 5 to 17. Here's what they asked me. Use the Riemann sum to estimate the average value of f. Okay, I need to make this clear to you guys. When they say find the average value of f, then when you write your formula is 1 over b minus a integral of f of x dx. If they say find the average value of f, then you put f here. They don't always say find the value of f. Sometimes they say find the average value of velocity. If they say find the average value of velocity, okay, then you would put velocity here. Does that make sense? Sometimes they say find the average value of speed. If they say find the average value of speed, then you put speed here. Does that make sense? Whatever they say find the average value of, that's what you would put in. And here's even a trickier thing. If they say find the average value of f prime, you would put f prime here. Does that make sense? Whatever you want the average value of, that's what you would put here. Okay, so here they're saying find the average value of f, so I would put f here, f of x dx, okay? And this is b minus a, so this is a to b. My a and b in this picture is 5 to 17, okay? So replace your b and a, 17 minus 5, from 5 to 17, f of x dx. But guys, do I know what this is? Yeah, this is 359. Is that right? 359. So this is really 359 over 12. 29 point what? Oh, you're doing it in your head. If you do it, if you leave it like this, you have the exact answer. You guys good with that? You don't have to put it in the calculator. But if you do put it in the calculator, make sure you go 3 decimal places, either truncate at 3 or round correctly. Okay, but you can just leave it just like this. All right, any questions on average value? Okay, so quickly, just to look over your homework, guys, I'm going to check your homework, and you guys have some time to work on homework, which is nice. But the first 3 problems, if you want, you can use a calculator. Actually, number 1, I would strongly suggest using a calculator. Number 2, you could probably do it by hand. Actually, I did number 2 by hand. It wasn't bad. Number 3, I'm not sure. Probably go with a calculator on that. But feel free to use a calculator on 1 to 3. Then you have a problem kind of like what we just did, number 4. Number 5 through 10, 5 through 13 are all reminding you about what second fundamental theorem of calculus is. Number 14 is a problem similar to kind of what we did just now also. And the number 15, I just want to talk to you guys about. You've got this curve on number 15. Okay, and they're saying use a midpoint Riemann sum on it. Okay, and so it's the curve looks like this. It goes above the graph and below the graph. Okay, when you do a midpoint Riemann sum, get your intervals, whatever your intervals are. Okay, when you divide it in the number of intervals they want, and I actually don't know, so I'm just randomly dividing here. Okay, I probably should have made that bigger. If they say midpoint Riemann sum, which is what they're asking for here, if these are the subintervals, okay, do they even tell you how many subintervals they use? They don't. So you can do, oh, they do? Oh, it does 4. Okay, so definitely I've got way too many going on here. Okay, so you would pull from the midpoint. Wherever you hit your y, that's your rectangle, right? So if I pull from the midpoint, wherever I hit my y, that determines my my height. Does that make sense of my rectangle? Go from the midpoint, hit your y. Okay, and of course, I've got way too many rectangles here, but you guys get the drift. But on this problem, do you guys see that you actually have some positive, so hit my y, and then hit my y. Some positive rectangles and some negative rectangles, right? The integral, you guys need to understand, which I think you do understand, okay? The integral is actually the net area, okay? So you would add the positives, subtract the negatives, and whatever your answer is, that is the answer, okay? If the answer turns out negative, then it's still negative, okay?